Algebra students. Mr. Lawrence here with your next foot lesson, and today our lesson is on parallel and perpendicular lines. Now I know some of you, I asked you this question a week or two ago, more than a week I guess, definitely 2 weeks. What makes two lines parallel? And a lot of you want to say, well, you know, that when there are the two lines, the same distance between them is always the same, then you have parallel lines. And I'm not saying that that's not true, but we need a more effective definition. And hopefully we'll discover it. I know some of you already figured it out, but let's consider these three lines here. They're all written in slope by intercept form. I'm going to graph all three of them on the same graph. Oh no, Sage is thinking, Mr. Lawrence said not to do that. He's contradicting himself. Well, I'm doing it on this one to make a point. And if you're doing some parallel perpendicular homework, Sage, and you want to graph those two on the same graph to demonstrate, well then, I have no problem with that. Okay, so I'm going to graph the black equation. That is not the line for the black equation. I find my y-intercept is -2. And my slope is 3 over 1. So I go 1, 2, 3, 1, 1, 2, 3, 1. I feel kind of like the Witch's Guards in the Wizard of Oz. Oh, wee, oh, oh, oh. All right. So I go 1, 2, 3, 1. That doesn't sound like the Witch's Guards. And there is my black line. Okay. Now I'm going to do a blue line. And a blue line has a y-intercept of 5, 1, 2, 3, 4, 5, and a slope of 3 over 1, 1, 2, 3, 1, down 2, 3, back 1, down 1, 2, 3, back 1. Okay, and look at this. These lines indeed look like they're parallel. In fact, they are. I knew you knew that. I can't fool you guys. You're too smart. All right, line style. There we go. All right, but now let's graph the red one. The red one is y equals -1/3 x. Some of you are going to get freaked out about that. You are honors algebra students. You should know that's the same as having +0 on the end. So that one is going through the origin. The y-intercept is 0. Now, let me get rid of that because we don't write that 0 in there. Why not? Because we always give the simplest answer. All right, so from the red one, we're going to go down 1, right 1, 2, 3. Down 1, 1, 2, 3 to the right. And from the origin, up 1, 1, 2, 3 to the left. And I'm going to draw my line just like this. And let me change the color of it. Okay. And there you go. The red line appears to be perpendicular to both the blue and the black line. And by the way, before Algebra 1, all you could do is say, well, it looks like it's perpendicular. Now you can prove it. How? Check it out. The slope of the black line is 3, or 3 over 1. The slope of the blue line is 3 over 1. So the black line and blue line are parallel, right? But the slope of the red line is -1/3. What relationship do these have to each other? Well, perpendicular lines, the slopes of perpendicular lines are negative reciprocals of each other. The slopes of perpendicular lines are negative reciprocals of each other. So I was saying the slopes of perpendicular lines are negative reciprocals of each other. And I'm sure I misspelled that because I didn't even put a C in there. Mr. Lawrence, what are you thinking? Oh man, I'm just having trouble all over the place. There we go. All right, thank goodness for a spell check, right? Okay. The slopes of perpendicular lines are negative reciprocals of each other. Of course, the slopes of parallel lines are the same, right? That's true. That's what we just discovered using the black, blue, and red line. All right, let's try it again. And we have this black equation, which appears to be written in standard form. So I'm going to use my standard form shortcuts. First, I'm going to find the y-intercept. And to find the y-intercept, I'm going to do c divided by b. And when I take c as 6 and b as 3, I know my y-intercept is 2. 1, 2. Okay. My slope is negative a over b. I almost wrote b there, silly Mr. Lawrence. Down to 1, 2, 3. Down to 1, 2, 3. Up to back 1, 2, 3. All right. Up to back 1, 2, 3. And there is the black line. Ha ha. Okay. Second one, the blue equation is written in point slope form. So I'm going to find the point, which will be negative 1, 2. There's a point. It's not the y-intercept, but it gets me a point on the line. Now, my slope is negative 2/3, so I'm going to go down 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And these guys are very tight. 1, 2, 1, 2, 3. Very close to each other. Because they are, I'm going to do this with the smartboard. I love my smartboard, by the way. Watch this. When I clone that line, I get the parallel one to it. And I don't have to redraw it. I can just put it right there. And I guess I can make that blue for you so that you know which line I'm talking about. You don't have to go back and say, wait, which one? All right, so there's a black line and there's the blue line. All right, the red line appears to be in standard form, so I'm going to go looking for the y-intercept. Y-intercept will be c over b. Well, c is 4, b is negative 2. Therefore, it occurs at negative 2. So I go down 2 on the y-axis. And then my slope is negative a over b, which will be negative 3 over negative 2, which is better said as 3 over 2. So I'm going to go up 1, 2, 3, right 1, 2. Right, 1, 2, 3, 1, 2. And from the original point down, 1, 2, 3, back 2. And I only do so many points because they help me draw a more accurate line. So, let's do it from here. And look at that. It looks like I'm getting 90-degree angles where those lines intersect. And that is the definition of perpendicular. All right, that's going to be the lesson for today. Remember that parallel lines have the same slope. Perpendicular lines, their slopes are negative reciprocals of each other. We're going to write some equations with those, figuring out, the equation of a line parallel to a given line or perpendicular to a given line. But that'll be for tomorrow night. So, Mr. Lawrence signing off. Good night, everybody.